Okay, so you have here a rectangular beam. Say for example, you have a rectangular beam. Okay, and this is reinforced on the tension side. And diba, and say for example, this is the neutral axis. Okay, then if we try to draw the stress diagram, okay, and these stresses can be represented by a single force acting on its centroid, diba? This is denoted by C for compression, and of course, due to the reinforcement in the tension side, you have there what we call T. Okay, and this C is acting on the what we call now the compression block, diba? This one, and this distance, this is what we call the depth of the compression block. Okay, ito naman, this is your C, the distance from the neutral axis to the extreme fiber in compression. Okay, so kailan ba nagkakaroon ng doubly reinforced design? 'Di ba if we try to draw the if we try to draw the strain diagram, okay, it would look like this. The strain for concrete is 0.003. 'Di ba? That is the strain for concrete, and the strain naman for tension, that is for steel pala, 'di ba? This is equal to Fs over yung modulus of elasticity ng steel, but this is the value for the strain sa steel. That is the value for the strain sa steel. And if we want to have a balance design, ibig sabihin, yung pag sinabing balance, sabay lang na mag-yield yung steel at saka yung concrete. Sabay nila na ma-reach yung kanilang strain. Okay, sa concrete, that is 0.003. At saka sa steel naman, that is equal to, this time, instead na Fs dito, this is the yield point, the Fy, over the modulus of elasticity. So, if this is a balanced design, yung Fs mo, this is actually equal to Fy over the modulus of elasticity. And if you try to compute this, this is approximately equal to 0.002. Okay? So this is the strain of the steel for balance design. Okay? Sabi sa NSCP, kailangan talaga na tension controlled. Ibig sabihin, kailangan na mauunang mag-yield yung steel natin. That's why, yung NSCP, sabi niya, kailangan hindi lang 0.002, kailangan hindi aabot sa 0.002 yung strain mo. It should be, the minimum strain only should be equal to 0.004. That is to ensure ductile failure. Ibig sabihin, dapat tension controlled. Yun yung sabi sa NSCP. So, ibig sabihin pala, iniiwasan natin na below 0.004 yung strain natin sa tension. Kasi kung below 0.004, ibig sabihin nun, malapit na siya sa 0.002. And if that happens, mauuna nang mag-fail yung concrete natin. Iniiwasan natin yan, di ba? Kasi gusto natin na tension controlled yung design natin, di ba? So one logical solution para lang hindi mauna mag-fail yung concrete is to, of course, you can increase the area of the concrete in compression, 'di ba? Just so it will not fail first. It will not yield first, okay? Para lang hindi siya maging compression controlled. Okay? Pero there's a concern kung masyadong, kung palakihan mo yung kung palakihan mo yung area ng concrete, baka naman masyado na siyang malaki, 'di ba? Baka naman masyado nang malaki yung dimension ng beam mo. And that is we don't want that also, because baka it will take up too much space sa design mo. Also, baka there's a concern na baka masyado ng mabigat yung beam mo. Okay? So, masyadong malaki yung dead load. Okay, so what we do instead na palakihin natin yung dimension ng concrete natin para lang hindi siya mauna mag-fail, di ba? Yung ginagawa natin instead is nilalagyan natin ng reinforcement, compression reinforcement, steel reinforcement at the top. Tawag dyan is compression reinforcement. Okay? So, naglalagay tayo ng compression reinforcement at the top. Okay? Kasi, mas malakas naman yung, di ba? Mas malakas naman yung steel kaysa sa concrete. Diba? If you compare the FC prime and FY is larger than FC prime. Yung capacity ng steel natin is mas malakas siya kaysa sa capacity ng concrete. Yun nga lang, mas mahal yung steel, di ba? So, instead na palakihin natin yung concrete in compression, 'di ba? Nilalagyan na lang natin ng ano, ng compression reinforcement at the top. Kasi maliit lang na area kung steel yung gagamitin natin. Instead na palalakihin natin yung ano, ng area ng concrete. Okay, so yun yung ginagawa natin. Now, because of the tension reinforcement, meron kang another force here. Let me erase this one first. Now, because of that reinforcement, you have another force here in compression. Okay? This force here is now acting on the centroid of that reinforcement. Okay? So, itong force na to is from that reinforcement and we call this CS. Okay? Compression from steel. Okay? That is CS. Okay, so naglagay ka ng additional reinforcement sa taas. Of course, maglalagay ka din ng additional reinforcement at the bottom. Okay, yun. So this force here is this is also tension. So since dalawa naman silang tension, let's name this TS1 and this is TS2. Yan. Okay, so we have two couples here. Okay, for this to be in state of equilibrium, your C and your TS1 should be equal at saka yung CS mo at saka yung TS2 should be equal para maka-form ka ng dalawang couple. Okay? The magnitude of the couple here is denoted by Mn1, okay? Mn1, and the magnitude of the couple here is denoted by Mn2. Okay? So the sum of the two is the total nominal capacity of the section. Okay? So your Mn, the capacity ng section is actually equals to the Mn1 plus Mn2. Okay? Where your Mn1, take note, your Mn1 is actually equal to, it's either C multiplied by D minus A over 2 o kaya naman your Mn1 o kaya naman your Mn1 is also equal to T multiplied by D minus A over 2. Diba? Yan. Yung Mn2 mo naman, Mn2. Your Mn2 is equal to the magnitude of the couple here. That is CS at saka TS2. Okay, so you can write here your Mn2 is actually equal to CS. Okay, CS multiplied by D minus D prime. Saan ba nakuha yung D minus D prime na yan? Diba this distance, the distance from the extreme fiber to the centroid of the tension reinforcement is your D. Okay? At saka yung distance naman, di ba, the distance of the reinforcement in compression to the extreme fiber in compression is denoted by D prime. Di ba? So, ibig sabihin, this is also D prime. So, the distance between the two reinforcement is actually D minus D prime. Di ba? D minus D prime. This is the distance between the two reinforcement. That's why your moment arm here, CS is equal CS multiplied by D minus D prime. Yan, the distance between the two forces. Okay, this also equal to your Mn2 is also equal to is also equal to TS2 multiplied by D minus D prime. Of course, this is TS1 ha, TS1 at saka ito naman this is CC. Okay, CC. Compression from concrete. Okay, so these are the formulas for Mn. Also, we have to identify ano ba yung value ng CC. CC that is 0.85 FC prime AB. Diba? That's the value for your CC. Okay, this CC. How about your CS? Your CS is equal to, that is AS prime to denote that it is in compression multiplied by Fs prime or Fy. Okay? Fs prime or Fy. Okay, and your TS1 naman, TS1, this is also equal to AS1, not prime ha, walang prime kasi this is in tension, multiplied by Fs. Where your Fs, the maximum value of your Fs is your Fy. Okay? And also you have there the TS2, this is equal to AS2 multiplied by Fs. Where the maximum value of your Fs is Fy. Okay, so these are the formula we will be using in solving or in the design and analysis of a doubly reinforced beam.